Welcome to the Masking Handbook for Audiometry. In this video, we'll be looking at word recognition score testing, how to use the wrsMAX calculator. We just need to enter two pieces of audiometric information into the wrsMAX calculator, and we can determine the following values. The calculator defines a maximum WRS test level, and it will also quantify an appropriate but safe level of masking. This sounds like it could be helpful. We'll need to enter the following two items. We'll enter the best bone conduction hearing threshold level from the test ear. So for example, if we're completing WRS testing on the left ear, we'll find the best bone conduction threshold from that left ear and enter it into the spreadsheet. And we'll enter the largest air bone gap from the non-test ear. Once we have these values entered, the wrsMAX is calculated along with the masking level. The calculation is based on the min-mask plus 5 method of masking, along with estimating a maximum masking level allowable for a given situation. The min-mask plus 5 approach quantifies the amount of possible crossover that might occur from the test words delivered to the test ear, and it also compensates for any air bone gaps that might be present in the non-test ear masking side. Let's take a look at two different audiograms and see how the different configurations might affect our WRS test approach. In these examples, we'll use insert earphones as the transducers. In this case, we have a unilateral conductive hearing loss in the right ear, with normal hearing in the left. Let's take a look at testing the right side first. The two items that we'll observe will be the best bone conduction threshold from the test ear, the right side, and the largest air bone gap from the non-test left side. Here, the best bone conduction threshold from the right ear is 5 dB, and the largest air bone gap from the left side is 5 dB as well. Let's enter these values into the spreadsheet. We'll enter 5 dB as the non-test ear largest air bone gap, and we'll enter 5 as the best bone conduction threshold from the test ear side. And we see that the highest possible level of testing for WRS in the right ear is 90 dB, and the maximum safe masking level to the left side would be 50 dB. Let's take a look at another audiogram configuration. Let's look at testing the left ear. We'll get the largest air bone gap from the right non-test ear, which is 35 dB, and the best bone conduction threshold from the left test ear, which is 40. So the largest air bone gap is going to be 35 dB. That's from the right ear. And the best bone from the left ear is 40. We'll enter these. And we get a WRS max value of 95 dB for testing the left ear with a prescribed maximum masking level of 85 dB. The WRS method and calculator can be very helpful, but it does have a weakness. The ultimate test level is based on an appropriate but safe masking level, and the WRS test level is calculated with this in mind. In other words, the system as it currently stands does not consider what a maximum unmasked WRS test level might be. For some audiometric configurations, it may calculate a test level that is actually lower than if the test was completed with no masking at all. An additional item was therefore added to the calculator in order to configure a maximum WRS unmasked test level. The unmasked test level is based on the min-IA for WRS testing and the best bone conduction hearing threshold from the non-test ear. In order to calculate this, we just add a single piece of information to the calculator in addition to our two original pieces of information. Let's try testing the right ear with this audiometric configuration here. In this configuration, we have an air bone gap in the non-test ear of 45 dB. And we have a best bone conduction threshold from the test ear of 15 dB. All right, we have a non-test ear air bone gap of 45 dB and a test ear best bone of, what was that again? 15 dB. And so we have an wrsMAX level of 60 with an maximum masking level of 60 dB as well. If we look at the hearing on the left ear, though, we see a masking level of 60 doesn't really make any sense because it's below the hearing levels of that ear. So that's what I mean when I say this method doesn't consider the hearing of the non-test ear, the actual air conduction hearing. So let's check out and see if we can find an unmasked test level that would work. So we just add our one single extra piece of information, which is the non-test ear best bone, and that's 25 dB. We'll enter that in. And now we see we have an unsafe and appropriate unmasked WRS test level of 70 dB. So for some situations, this unmasked approach may work best. It may give you the higher test level, and the whole issue of masking may make more sense. We hope you'll find the wrsMAX calculator to be helpful for WRS testing, particularly when trying to mask a non-test ear that has some kind of conductive hearing loss present in that ear. You'll find the wrsMAX calculator spreadsheets for insert earphones and supraoral headphones at maskinghandbook.com. This is the Masking Handbook for Audiometry. If you liked this video, you'll love the handbook. For more resources on masking and to learn how to purchase the book, check out maskinghandbook.com.